Good afternoon, children. Let us talk with the 8th class maths, first chapter, rational numbers. Before going to the topic, let us have a discussion about a proverb. The proverb says, today's proverb, bad cause needs many words. What is the meaning of bad cause, children? Bad cause means you have done a mistake, suppose. You don't want to accept it. We might have come across with many people like that. They do the mistake, but they don't accept it. So, if they don't accept it, what do they do? They will try to convince us that they are right. So, to convince us what they will do, they talk a lot many things. So many examples they will give, so many reasons they say, and they say ultimately that this is the reason why I have done. I'm right, no. But if the thing or if the work, whatever it is, if that is wrong, that is incorrect, let him try to convince in any language, in whatever best way he can. He cannot. Why? Because it is wrong. So one should have the guts to accept the mistake and try to learn from the mistake and proceed with the correct procedure. So that guts one should have in the life, children. Don't try to see that or don't try to convince the people for your mistakes. You accept your mistake and say sorry to them and say that I'm not going to do this again. Give me a chance. That will make a good rapport with the people around us. Let us come back to our topic. It's rational numbers. I am doing commutative property. Commutative property of natural numbers I have already done. Now I am doing whole numbers. In whole numbers, the first topic is under addition. Again, the same definition, children. If A and B are two whole numbers, then A plus B is equal to B plus A. So let us take A as 2, B as 6. What is A plus B, children? 2 plus 6, 8. What is B plus A? 6 plus 2, this is also 8. So what you are getting? A plus B is equal to B plus A. What do you understand with this? Commutative property exists. Commutative property exists for whole numbers under addition. So this is the definition, children, and this is the way in which you are explaining this commutative property. What does the commutative property says? If A and B are two whole numbers, then A plus B will be equal to B plus A. So we have got them as same. So we are saying that commutative property exists for whole numbers under addition. So please note it down. Now we will go for commutative property under subtraction. What is this under subtraction? Subtraction means what, children? Minus. Same definition, but you will say that A minus B is equal to B minus A. A is equal to 2, B is equal to 6. So, A minus B, 2 minus 6, how much 2 minus 6? Minus 4. B minus A, 6 minus 2, 4. Are they equal, children? Minus 4 and plus 4 are not equal. So, we will say that A minus B is not equal to B minus A. What do you mean by this? It says that commutative property does not exist for whole numbers under subtraction. So this is commutative property of whole numbers under subtraction. Now we will go for third bit under multiplication. If A and B are two whole numbers, then A into B should be equal to B into A. So, A into B, 2 into 6. How much 2 into 6? 12. B into A, 6 into 2 is also equal to 12. What are you getting here, children? A minus A into B here. A into B is equal to B into A. So what you will say? Commutative property exists for whole numbers under multiplication. Write down this, children. This is about multiplication. Now we will go for division under division. So if A and B are two whole numbers, A divided by B should be equal to B divided by A. So what is A divided by B? 2 divided by 6. So how will you write this? 2 divided by 6. 2 by 6, 1 by 3. Now B divided by A, 6 divided by 2. That means 6 by 2. 2 ones are 2 threes are. So 3. Are they equal, children? 3 is not equal to 1 by 3. Therefore, A divided by B is not equal to B divided by A. What do you mean by this? Commutative property does not exist for whole numbers under division. Copy it, children. So all the 4 operations we have done. Now this is a fourth one, children, under division. All the 4 operations I have done. Now we will go for the table. The table whole numbers. So the number system is whole numbers under addition, under subtraction, under multiplication, under division. Under addition, you are getting commutative property. Under subtraction, you are not getting. Under multiplication, you are getting. Under division, you are not getting. So, this is the table for commutative property of whole numbers under addition, subtraction, multiplication and division. Now, we will go to the next number system, that is integers. For the integers, again, first one under addition, if A and B are two integers, then A addition plus B is equal to B plus A. This is addition property, children. So, let us suppose A is equal to -4, B is equal to 3. I am taking this. Now, go for A plus B, -4 plus 3, -1. B plus A, 3 plus of -4. 3 minus 4. How much, children, you are getting? -1. Either you see A plus B or B plus A. You are getting them as same. A plus B is equal to B plus A. Therefore, commutative property exists for integers under addition. So, there is commutative property for integers under addition. Copy this, children. Now, the second bit under subtraction. Under subtraction. If A and B are two integers, A minus B should be equal to B minus A. So, A minus B. -4 minus 3. I will get -7. Now, B minus A. That is 3 minus of -4. Okay, minus is this side. -4 is A value. So, minus of minus becomes 3 plus 4. This will be 7. Are they equal? You are not getting them as equal. A minus B is not equal to B minus A. So, commutative property does not exist. Commutative property does not exist for integers under subtraction. Note it down, children. This is the second one under subtraction. Now, we will go for under third bit, under multiplication. Under multiplication, if A and B are two integers, A into B is equal to B into A. So, A into B. -4 into 3. How much, children? Sign, if you multiply -4 3s are 12. So, B into A. 3 into minus 4. Again, plus into minus minus, 3 4s are 12. So what are you getting? A into B is equal to B into A. So we will say that commutative property exists for integers under multiplication. So copy this, children. This is the third one. Now we'll go to the fourth part under division. Under division. If A and B are two whole numbers, two integers, A divided by B is equal to B divided by A. So here you are going to get A divided by B, B divided by A. This is 4 divided by 3. What is minus 4 divided by 3? Answer is minus 4 by 3. And 3 divided by minus 4. 3 divided by minus 4, you will be getting it as 3 by minus 4. Okay, children? 3 by minus 4. But the thing here is, even though you are getting those values, minus 4 by 3, 3 by minus 4, how much it is? Minus 3 by 4 you are getting. See, children, first thing is they are rational numbers we are getting as answer. But and the other thing what you are getting is numerator and denominator. Reciprocals you are getting. So what you will be saying that A divided by B is not equal to B divided by A. So we will say that commutative property does not exist for integers under division. Under division, it is not possible, commutative property. So I hope you have followed, children. Copy this. Now we'll be doing the table of these integers. What is the table for integers? This is integers for plus, addition, subtraction, multiplication, division. Okay, now there exists addition, subtraction won't exist, multiplication exists, division won't exist. So these are the properties of integers, children. I will do the next part in the next class.